So let's just try a couple of problems from the textbook. Here's problem 2 from page 726. And it says, use your wits to construct a DFA for each of the following regular expressions. And it gives us a bunch of different regular expressions that we need to make a DFA for. And in fact, I haven't double checked. It's possible that in the errata they have a fix for this question. But actually, I've got a problem with this question, which is that they don't tell us over what alphabet we're considering. And of course, since we need an out transition for every single letter of the alphabet, we need to know what alphabet we're going to use. So let's do these problems and we will just decide what alphabet we're going to use. It's pretty obvious that what the textbook author thought we were going to do is just use the alphabet A, B, C, right? The alphabet that contains 3 symbols, A, B, and C. I can even draw it for you, right? So A, B, and C. So let's use this as our alphabet for our first problem, right? So we'll say we want to do, figure out the answer. We want to build a DFA for the language that's represented by the regular expression A plus BC over the alphabet ABC. Okay. So what is A plus BC? Let's pause and think about that for a minute. The plus, you remember in regular expression, is kind of like union, right? So in fact, this language here, if we want to talk about it, we could say that the language of A plus BC, well, that's just the set containing 2 strings, the string A and the string BC. So we need to build a DFA that will recognize the language that contains 2 strings. Language that contains the string A, language that contains the string BC. And if we give it to the string A, it should say, yes, that's in my language. If we give it the string BC, it should say, yes, that's in my language. If we give it any other string, it should say, nope, that's not in here. Okay, so let's do it. So, of course, we need our start, right? And here is a state or a node, and there's nothing that says the start state has to be 0. We often will call it 0, but I mean, I can call it anything. I could call it Fred if I wanted to. Why don't we call it, I don't know, state 4, just so you know I can call it whatever the heck I want. The start state is going to be state 4 in this case. And let's see, if we see just an A, we want to accept that. So what I often do when I'm trying to figure these problems out is I figure out how to get all the things that I need to have accepted, and then I deal with making sure I reject everything else. So let's start by making sure we accept the string that's just the letter A. So what I'm going to do is I'm going to have a transition here with an A, and that'll go maybe to state 0. And state 0 is going to be an accept state, so I will give it a double circle. Okay? So now we're going to accept the string A. We also need to accept the string BC, so let's say if we had a B here, maybe that goes to state 1, and then we have a C, and that goes to state 2, and of course state 2 is also going to be an accept state. So this is great. We accept the string just A, or if we see a B and then a C, we accept that too. And now we need to make sure we don't accept anything else. So let's start with our first state here, which is called 4. And let's see, I have an out arrow for A and an out arrow for B. But if I see a C, I need to reject that, right? So if the first letter I see is a C, I need to reject that because there's no strings in my language that start with a C. Okay, so let's do it. Let's say Here's state, what are we up to? State 3. And if I see a C, I go to state 3. And by the way, once I'm in state 3, I'm never going to accept anything. If I see a C, I'm never going to accept anything after that point. So I'm going to add a loop right here while I'm thinking about it. It's going to say, if I get an A or a B or a C, just stay in state 3. Because it's kind of like a black hole. It's a trash state, I sometimes call it. If I'm in 3, I am stuck there. I can never get out, and I don't accept. Okay, so from state 4 here, we have an A, B, and C going out, so that's good. And state 3 has A, B, and C going out, so that's good. What happens about state 0? So if we've seen an A, we accept. But after we see that A, if we see anything else, we reject, right? Because the only string that has an A in it is an A by itself. So we need to reject if we see anything else. So in fact, one thing that I could do is I could say, you know what? I'm going to have another arrow to state 3. And if I see an A, B, or a C, after I see that first A, right? So if I see an A, and then I see any letter after that, I'm going to go to state 3, and then I'll just be stuck here. Right? So that's pretty good. So let's go through this again. State 4 has an out arrow for A, B, and C. State 3 has an out A, B, C. State 0 has an out B, A, B, C. Let's see state 1. State 1 has an out arrow for C. So if I'm in state 1, it means I've already seen the letter B. And the only thing that I should accept after this is a C, right? So if I'm in state 1 and I see an A or a B, all is over, right? I can't accept anymore. And one thing I could do is I could just have an arrow from, here on state 1, I could somehow try and get an arrow round over to state 3 that says if I see an A or a B, then you go to state 3, which is my trash state. But you know what? This picture is messy enough right now. I think I'm just going to make a new state over here, because I can make as many states as I want, called state 5. And if I'm in state 5, I go to state 5 if I see an A or a B from state 1. That's a B, right? And once I'm in state 5, it's another state where I'm just kind of stuck, right? I don't want to get out. I don't want to accept. So we're going to do another one of those loops with A, B, and C. And just remember that this loop here corresponds to 3 distinct loops, right? There is one loop that is an edge for A, one loop that is an edge that has a B label, one loop that has an edge labeled C, and we just decided to put all 3 on there. Okay? So let's see where we are. We need to check and make sure that every state has an out arrow for every letter, and I don't think 2 does yet, right? So if I'm at state 2, which is an accept state, it means so far I've seen the string B, C, which is great because BC is in my language. But if I see anything after that, an A, a B, or a C, then I'm not in the language anymore, right? So for example, let me write up at the top of the page. I'm running out of room here. If I see the string that's a B and then a C and then another C, well, I don't want to accept that, right? Because BCC isn't in my language. A is in my language and BC is in my language, and that's it. So if I see anything after I get to state 2, I want to reject. So what I'm going to do is I'll put a little arrow there, and I'll say if I see an A, a B, or a C once I'm in state 2, then I should just go to state 5, and remember that once I get to state 5, it's like state 3, everything's done, right? I can't get out of state 5, and it's not an accept state. So I think this is pretty good. Let's just check. 0 has an ABC out. 1 has an ABC out. Sorry, I can't help starting counting at 0. 2 has an ABC out. 3 has an ABC out. 4 has an ABC out, and 5 has an ABC out. So all of my states have an out transition or an out arrow that's for A, B, and C. And in addition, if I see just an A or I see a B and a C, I accept, but everything else I reject. So I think we're pretty good. I think we've done it. I think this is a DFA that accepts the language A plus BC. So let's try again now, and this time let's make a DFA that accepts this language. But just for fun, why don't we have it accept this language over the alphabet A, B, C, D. Okay? And I want to do that just to show you that, you know, you have to tell me the alphabet, because every single letter of the alphabet is going to have to appear as an out arrow for each state. Okay? So let's do this problem for a minute. Okay, so I think we need a little bit more room, so let's do it here. So what do we need to do? We need to recognize AB star plus C. So let's just think about what AB star plus C is. AB star plus C is the language, well, let's see. It accepts the string A, and it accepts the string AB, and ABB, and ABBB, right? So that's this part, the AB star, and this C is just that set, right? The set containing C. So our language AB star plus C is really the union of these two sets, right? So we have this first set and the second set, which only contains one thing. So infinite set, set containing the letter C. Okay, so that's what our DFA needs to recognize. Okay, so let's do it. So let's see, let's just start with 0 this time. We don't have to be creative. And let's make sure we write start. And what do we need to do? Let's deal with C first, because that's easy. So if we see the letter C, or the symbol C, right, we will transition to state 1, which will be an accept state. And so now we just need to think about this AB star thing. So we need to see an A and then as many B's as we want, right? So if we see an A, we get to state 2. We don't accept yet. Oh, actually, I guess we do, right? Because if we see an A and 0 B's, that's okay, right? So let's turn that into an accept state. And then, of course, if we see 1 more B or 2 more B's or 3 more B's or 50 B's, we still accept. So I think at this point, we accept the string C, right? And we accept all the strings that start with an A and then have 0 or more B's, right? Because we'll accept C. We'll accept A followed by 0 or more B's. Okay. So now we just have to make sure we reject everything else, right? So if we start at state 0 and we see the letter B, we immediately reject, right? So let's make another one of these sort of trash states, right? Let's do an arrow like this. And let's make state 3. And let's make state 3 be kind of a never, never land, right? If you get to state 3, you do not accept, and even worse, you're stuck there, because no matter whether you see an A, B, a C, an A, B, a C, or, I forgot, we said we were going to do this over the alphabet, A, B, C, D. So if you see an A, B, a C, or a D, you are stuck in state 3. And I guess you transition to state 3, right? You go over here to state 3, not only if you see a B, but also if you see a D, right? Okay, so that takes care of state 0, because no matter what letter we see in the alphabet, we're okay. State 1, well, if you get to state 1, you only accept if you see the letter C, right? So if you just see a C, you're in state 1. But if after you see the C, you see anything else, you need to reject, right? And this state 3 here is sort of my definitely reject everything state. In fact, sometimes I will like put a little dot or something there just to remind myself that's going to be my trash state. That's going to be a state which is going to reject everything. So if I'm at state 1 and I see anything else, and in this case anything else, I know because my alphabet has A, B, C, and D in it, anything else must be an A, a B, a C, or a D. I reject. So we've got state 0 is taken care of. We have out transitions for every letter. State 1 has out transitions for every letter. State 2, if we see a B, we're in good shape. But if we see an A or a C or a D, we need to reject, right? And I think we may be good. State 3 has all the out arrows. So there you go. This looks pretty good. So let's do that last problem. And we need to construct a DFA that recognizes this regular expression. And let's do it over the alphabet A, B, C. We'll just make our lives a little bit easier and just do it over the alphabet A, B, C. Okay, so let's do the easy part first, right? Let's construct the DFA that will recognize just this little piece, AC, right? AC is just a single string, right? And this, of course, because we have the plus, it's the union of this language with that string. So we do our start, and we'll have a state that has an A transition followed by a C transition, and we will accept that second transition, and this looks good. We're accepting AC. But now it gets trickier because in addition to accepting the language AC, we also need to accept the language that starts with 0 or more A's, then has a B, and then ends with 0 or more C's. So whereas before we could say, well, if it's got an A, it'll take this transition, and we could make anything that gets here to state 1 that doesn't continue with a C to be a bad state. Now, if we get here, we could see either a C, and that would be okay, or we could see many more A's or even a B, and all of those would be fine options. So we need to deal with that a little bit. So let's just kind of try and piece this together as we go. Some of this is, I would expect that my wits would be better than your wits right now because I've done this a little bit more. But try and follow along, and let's see what we do. So over here it says we can have 0 or more A's. So we've got the case where there's 1A. We know we end up at state 1 if we have 1A. If we have 0 A's, then things aren't too bad because we have to have a single B and then 0 or more C's. So let's deal with that one. So if we have a B, that'd take us to state 3. And at this point, let's see, we can now have, we had our B, so we could have 0 or more C's. So in fact, state 3 could in fact be an accept state, right? Well, state 3 has to be an accept state because we should accept a string that just has a B. But in addition, if we see any C's, 0 or more of them, we should accept also, right? So if we look at our graph so far, we're accepting the string AC, right? So because we started 0, we transition A, C, and we end up in an accept state, so that's good. We're also accepting the string that starts with a B and then has 0 or more C's, right? That's this path down here, right? So we have the case where we have 0 A's, right? That would be this path. That's still a good string. We don't have anything else, though, for the first part of this language, right? This first component. So let's think about it for a minute. If we see 1A and then a B and then 0 or more C's, we could, I guess, let's see, if we see a B now, we could transition to state 4, which would be an accept state, and then we could have 0 or more C's here, right? And that would take into account the state where we have exactly 1A, right? So we've got 0 A's and we've got exactly 1A. Now, one thing you might notice is we didn't actually have to create this state 4, right? So one thing I could do, and let me just change colors for a second here. An alternative to this piece here with the state 4 would have been to just draw a line like this for B, right? And use state 3, right? Just reuse state 3, right? Because state 3 accepts 0 or more C's. So either of these are correct. I'm going to go with the first one, so I'm going to get rid of that blue line. But that blue line was equally good if we had left out this piece here. Okay? All right, so back to where we were. We are accepting this AC is still good. We're also accepting all strings that start with 0 A's and then BC star, or 1A followed by BC star, but we don't have the case where we have more than 1A, right? Now, what we don't want to do, and maybe, let's see, let's get another color for something bad. Let's do this in red. What we don't want to do is we don't want to have an A loop here, right? Because if we had an A loop there, that would mean that we would accept, let's see, what strings would we accept that? If we had an A loop there, we could take an A and then do 2 more A's and then do a C. And that's not legitimate, right? Because we can have either 0 more A's with a B in the middle and then 0 more C's, or straight AC with nothing in between. So this A loop here is no good. So we got to get rid of that. And if we're not going to have an A loop, then I guess what we're going to have to do is we're going to have to have a new state. So let's draw out of here. And let's say what happens if you get to state 1 and then you see an A. So the one thing we know now is by the time you get to state 5, we have seen 2 A's, right? And at this point, we could see, let's see, as many more A's as we want, right? And then we have to see a B, and then we could see 0 or more C's, right? So at this point, we have a bunch of different options. One option is we could say, well, if I see a B, I'll transition to state 4, and of course once I'm in state 4 I can see my 0 or more C's in life is good. Another option is if I see a B, I could transition to state 3, right? And again, I see 1A, I see 2 A's, and then as many more as I want, then a B, and then 0 more C's. So that's another possibility. And the last possibility that I have is, of course, that I transition from state 5 to a new state using a B and then do a loop. So I could do something like this. I could say, all right, well, at some point I see a B, and then I have a state 6, And with that one, I get a loop with 0 or more C's, and that's an except state. I think this time we'll go with the slightly neater approach. So I'm just going to have an arrow from state 5 to state 4 that has a B on it. Okay? So at this point, our DFA, well, we don't have a DFA, right? Because there's no out arrow for every single letter in our alphabet. But what we do have accepts, I believe, every string that's in our language. So now we just need to make sure that we reject all the strings that are not in our language. And so let's see, if we're at state 0, then we have an out arrow for A and an out arrow for B, but we don't have an out arrow for C, so let's do that. Let's see. If I go down this way, maybe we can make kind of a trash state here and see if we can use that for more than just this node. So we're up to 6. So if I see a C, I'm going to go down to node 6. And once I'm at node 6, any letter that I see, an A, a B, or a C, stays at node 6, and 6 isn't an except state, right? So that's pretty good. If I'm at 1, if I'm at state 1, I have an out arrow for A, I have an out arrow for B and C, so 1's done. State 2 doesn't have any out arrows, so I guess, oh right, state 2 was from this piece. So if I see anything after I get to state 2, I need to fail. And while I could point an arrow from state 2 to state 6, but that's going to get pretty messy pretty quick. I'm actually running out of space here, aren't I? So let's make a state 7, and we'll point it kind of over here. So there's state 7, and state 7 is also going to be one of these states that once you get in it, you never leave. So there's A, B, and C pointing back at itself on state 7. So we've dealt with 0, 1, and 2, right? So 0 has an ABC out, 1 has an ABC out, 2 has an ABC out. Where's state 3? Here's state 3. Right now, state 3 just has an out arrow for C, so we need A and B to fail. Unfortunately, we've got state 6 there, so we can say go down that way on A and B. And for the record, I'm doing this with a stylus on a pretty small screen, so my handwriting is not the most beautiful, but if you're doing this for submission for a grade, please, please try and make everything as legible as possible. You won't be narrating while you're while I'm grading you, so it's important that I can see what's going on in your homework and understand it, or more importantly on your tests. Okay, so we are up to, we did state 3, has an A, B, C out. We're doing state 4 now. State 4 has C out, but no A and B. So I guess yet again we'll go down to state 6. So let's do that and say that's for A and B. State 5 has A and B out, but not C. So we will have C go out there. State 6 has A, B, and C in a loop, right? So that's everybody. Where's state 7? There's state 7 up there, A, B, C in a loop. So I think we checked everything. So I do think we have a DFA. It has start, it has a bunch of states, and it does accept this language. And you should take a look. You should redraw this yourself neatly, and then you should try it out and make sure it works for you. So here's a similar problem. This time we're starting with a DFA, and we're trying to find a regular expression that accepts the same language. So here's our DFA. We can tell just by looking at it that the alphabet is going to be just the set A, comma, B, right? And we know that, of course, because the out transitions, each state has an out transition for A, B. And while DFAs don't, as a rule, have to start at state 0, We tend to have our start at, say, 0, and this one, the start is at 0 again. That's fine. And it has one except state, which is the state 1. Again, we don't have to have any except states in a DFA, right? A DFA that has no except states just accepts the empty language, but in this case we do. So let's see. It doesn't accept anything if we start with a B. But if you have one A, then after that you can have as many A's or B's as you want and just stay in here. So all we have to be able to do is specify that language. If we were specifying that language as a set, we might do it as actually squishing together two sets. We'd start with the set A, and then we would concatenate that with the set of all strings that have 0 or more A's and B's, whatever the letter that might be. So first you should just take a look at this and make sure that makes sense to you. And if that makes sense to you, then the regular expression falls out pretty easily, right? We have always an A, and after that it's followed by an A or a B, 0 or more of them. So there's that. Now some quick questions. First off, take a look at this slide and tell me why it isn't a DFA. For all these, you might want to just pause and look at it until you figure it out. And the answer, of course, here is there's no start state, right? We have to have a start state. Here's another one. We have to figure out why it isn't a DFA. And if we look, start state's good, so that's not the problem. And it's got a bunch of nodes and transitions. That's fine. Let's just see. We have A, B, C out of 0, and 1 has A and B, C. Oh, look at that. 2 has a state B and a state A, but state 2, there's no out transition for C. And actually it looks like that's true for state 3 too, right? So it's not a DFA if it doesn't have an out transition for each state. Okay, is this a DFA over the alphabet A, B? If it is, then what does it accept? If not, why not? Let's see, if we take a look at it, 0 has an out arrow for A and B, 1 has an out arrow for A and B, 2 has an out arrow for A and B, and 3 has an out arrow for A and B. So that looks promising. And there's a start. Now if you look, there's no double circles, right? So no except states. But that's fine, right? If you go back and look at our informal definition of a DFA, we didn't say that you had to have any except states at all. We just said that there was a set of except states. We didn't say it was a non-empty set. So that's fine, but since we don't accept any strings whatsoever, the language that we accept is the empty set, right? So we accept nothing, all the strings that are in that set, right? So in fact, you can refer to this using two squiggly braces with nothing in them. You can use it referring to the empty set symbol, which is in fact both the regular expression that represents the empty language and also the set notation that represents the empty language. Okay, one more problem. Find a regular expression that accepts the same language as this DFA. Right, so here's a DFA found on page 705 of the book. So let's see, what does it accept? If we look at this thing, start here, and if you take the A path, it looks like it's a single A, followed by as many B's as you want, followed by an A, followed by as many A's or B's, right? And the state 3 is an accept state. That's our only accept state if you look. So the first type of string that it accepts is an A, followed by 0 or more B's, followed by an A, And then at the end we can have as many A's or B's as we want, right? So I guess that's followed by A plus B, quantity starred. So that's one path, but of course if you look at this, we can also accept strings that start with a B, have 0 more A's, and then continue on with another B and then that mixture. So we want to say we can have either of these, so we'll have to say or, start with a B, have as many A's as you like, then one more B, not optional, those B's, right? But then after that, you concatenate that also with A plus B star. So there you go. Here's another problem. What is the alphabet of this DFA? Are you sure? Well, the alphabet of a DFA, if I tell you it's a DFA, it's pretty simple, right? If I tell you it's a DFA, then you just need to look at any one state and see what are the out arrows from that state. So we have A going out, we have B going out, we're done. That's easy. So the alphabet of this DFA is simply the set containing the symbols A and B. Another question? Are each of these legal DFAs? So we have a DFA that starts and accepts and then has this big loop. And notice, by the way, I called this one 23. Why not? So we do have start. Assuming it's over the alphabet A, B, then yeah, there's nothing wrong with this. But if you look, no matter what input you have with the symbols A and B, it accepts everything, right? So this is a totally legal DFA, and it just accepts the language A plus B star. Any combination of A's and B's you can find. In contrast, if we look at this other DFA here, well, I've called it a DFA, but yeah, it's a legal DFA. It has a start, has at least one node, it's got edges with out arrows for A and B, but no accept states, right? So this just accepts the empty language, right? The empty set. So here's another problem. We're asking for another regular expression that accepts the same language as this DFA. And you know what? This is the DFA is exactly the same as the first one on the previous page, except this node is called node 0 instead of 20-something, but there's nothing wrong with that. So this DFA accepts, oops, well, we're asking for regular expression. It accepts the set A comma B star, but the regular expression, which is what this problem is actually asking for, right, is A plus B quantity starred, and so that the professor who's grading us knows that we want to grade this one, we'll just give that a big circle.